Hello, everyone. Good morning, good afternoon, and good evening, based on wherever you are, and welcome. Thank you so much for joining us today in our today's session, Powering Your Future with AI series. I'm Mansa Rao, and I'll be your host for today's webinar. The topic we're exploring today is zero footprint data platforms, the rise of ephemeral ecosystems on AWS. Now, if you look at how most enterprises' data platforms are built today, they're still largely based on persistent infrastructure, clusters that are always on, capacity that's provisioned upfront, and systems that need consistent monitoring, patching, and scaling decisions. The result? High cost, operational complexity, and slower time to insights. What we're seeing now is a clear shift. Modern data and AI workloads are becoming event driven, bursty, and highly dynamic. They don't need infrastructure running 24/7. They need to compute only when the work needs to happen and nothing more. That's when the idea of zero footprint or ephemeral data platform comes in. These are the platforms where infrastructure spins up on demand, scales automatically, executes the workload, and then shuts down completely, leaving no idle resource behind. When done right, this approach fundamentally changes how organizations think about cost optimization, scalability, and operational overhead, especially on AWS. So today's session is about understanding what ephemeral's first architecture really looks like in practice, how automation, infrastructure as code, and AWS native services enable this shift, and how enterprises can start adopting this model without disrupting the existing data and AI workflows. So joining us today is Royston De Silva, Senior Lead Data Engineering at Exponentia AI. Royston brings over 13 years of experience across cloud data architecture, DevOps, and modern data engineering. He works closely with enterprises to design and build secure, scalable, and highly automated data platforms. With a strong focus on AWS and Azure ecosystems, he's also a DevSecOps evangelist, known for translating complex cloud native and automation concepts into practical real world architectures that support AI, real time analytics, and enterprise grade insights, all while keeping the costs and operational efficiency front and center. In today's session, Royston will walk us through how zero footprint ephemeral data platforms work in practice, how automation and AWS native systems services enable this model, and what this shift means for teams building modern and data and AI systems. With that, I'll hand it over to you, Royston, to take us through the session. Over to you, Royston.
Thanks, Mansa. So, yeah, can you present the slide, please? Yeah, perfect. So, before we begin, I want to put in a thought into all the participants in your mind. Do you ever pay rent for a house or an apartment which you don't own? A good question, right?
Yeah.
So if that's the story, why do you own data platforms or data ecosystems and pay for it when there's no data being processed in the background? This was one of the key problems with our traditional data platforms. You had so it was designed for a data which will start flowing like a river. There's no stopping. There's no peaks or hurdles at any point in time. Your flow will always remain smooth. This is what so it was basically over engineered for peak load and usually underutilized most of the time. So today we're going to look at how we design a data platform that scales when needed, but literally disappears when not in use. So I think so. Most of us have dealt with traditional data platforms at least once or twice in our careers. We have at least if not worked on it, we must have surely talked about it or heard from the senior folks in the organization. So what was the problem with the traditional platform and why cloud adoption became so common, or why was it the need of the hour? You had clusters which were running 24/7. You had a DevOps team which was equal in strength as compared to your data engineers, and instead of them looking at data, they were firefighting the infrastructure. So, and as I said, you are paying for the machines even when no one is actually either using the data or processing the data. So what were the problems? Your problems were persistent infrastructure, either on prem or on cloud, because you lived with the lift and shift approach. You had an operational complexity. Every time a security patch came in, or somewhere some particular thing went down, you had to allocate an entire bandwidth of a team just to fix your clusters. And because my infrastructure was frozen, the day I hit a roadblock and my data just arrives in a bulk, my insights become extremely slow in nature because I didn't really have the bandwidth to scale freely, or that was not baked in. So that's the reason today, this is a term which is commonly accepted or commonly noted, which is ephemeral. So let me explain what ephemeral means in a very short note. It's basically if there's no job running or there's no process which is triggered, there's no cost which is involved. So you don't pay a penny. It's like in a very layman terms, ephemeral or literal meaning of the word ephemeral is short-lived. So it lives only when it is needed. Else, the term which we can use it just shuts down or it disappears. So why, why ephemeral, or what are the key reasons to divert to ephemeral? The explanation is fairly simple. Your compute is temporary. You don't need to have machines which are running. You only your data is permanent, and that's stored. And anytime any particular event occurs, you ensure that the the data which flows or the process which gets kicked in, that is taken to closure, and the infrastructure should disappear after that. So quickly jumping on to what are the key principles of my ephemeral design. One is best, ephemeral always believes in stateless execution. So your compute is temporary. You don't need to have something which is pre-provisioned 24/7 running, waiting for the data to arrive. Rather, you let the data arrive in your system, and only when the data arrives, the infrastructure kicks in. Uh, the second thing is it's all event driven. So that event can be an automated event, like my data landing in a particular S3 bucket, or my SFTP kicking off an event, or it can be a basic yeah, it can basically be some notifications or something which are being processed or which are being generated by an IoT device or something else. It can be basically anything, even let's say a marketing manager kicking off a marketing campaign can very well be considered an event for our purpose. Or let's say a data or a senior data engineer trying to run a performance load, that's also very well quantified as an event, because it's something which requires action to be taken. And when that event occurs, based on the size of the event or the data that the event has generated, our infrastructure should scale to the purpose. So it starts with zero, but it has, or it should have the capability to scale to 100 or 1,000 based on what the requirement for the hour, or what that event is actually needing to be processed. And eventually everything is immutable in nature. So any configuration change that you push, we talked about a performance run which was supposed to be triggered. Let's say I want to run with two machines of 4 cores and 16 gigabyte of memory, and tomorrow I want to run the same process with, let's say, 10 machines of 2 cores each and 8 gigabyte of memory, so that I have more infra available for me, or whatever the situation is. All that configuration is immutable, as in, the previous run doesn't define or doesn't impact the new run. All this configuration or all of these is actually replaced in the system when the new process or the new job kicks in. So these are the key principles of ephemeral design. And yeah, so let's look at a very simple a demonstration here, where a, a very common scenario, right? So you might have an SFTP system, or you might be looking at generating a file, which when you push in the system, it should get auto processed to generate some insights. So here, what we have is a weather data file, uh, which has about a few 100,000 rows. And this data file, once I land this in my S3 bucket, my what I've used here is Lambda as an orchestration framework. So my event triggers a Lambda function, which will in turn trigger a glue job. This glue job will process the results. It will persist the results in a separate folder in S3 bucket, but parallelly send me a notification or SMS notification to say that the report was published and this is the insights that were generated from the report. So I'll quickly share my screen. Yeah, I have shared. Can
Let
someone
me
put
pull
up the
it up.
screen? Yeah,
Yes, yeah.
perfect. So, okay, so I'll briefly touch base on the components in use here, and then quickly go to a live demonstration. So we have a bucket called zero footprint ephemeral demo, which has an incoming folder, and it's expecting a file in this particular folder. This is an old file, so ignore it. uh, there is a lambda function which is running in the, or which is present in the background. Sorry, I'll quickly go to lambda. Yeah, and I'll show you that there's no any kind of preemptive start for this lambda function. It's not running in the background. It is just waiting for the event to be triggered. This lambda will trigger the job in turn, and eventually when the job completes processing, we'll be able to see the results. So let me do in or upload the file. I'll just push the file to the S3 bucket and click on upload. So yeah, so this has the file has been uploaded. Let's wait for the lambda, or the lambda will ideally trigger immediately. I can show you it to you in the monitoring, but it's more visible here when the glue job starts. We'll quickly look at the runs, and you can see that the run for this particular job has triggered about 7 seconds back. So we'll and so I'm not really going to look at what the script does. It quickly calculates standard deviation and correlation values between the rainfall and so it's a basic weather analysis that is being done. And what we have in this file is based on the standard deviation in my rainfall. I have categorized it as high, medium, low, or high, medium, moderate. And based on the impact of this or this particular rainfall, I have the impact score which calls it high or medium or low, and only the the high impacted cities with the actual values will be published to my mailbox. So let's go back to the run quickly and refresh it. Yeah, it should take a few seconds more, but we'll have the notification in our mailbox. And this should come here anytime now. Okay, the it has taking some more time. Yeah, so maybe I can quickly showcase an old existing report of what it generates. Give it a minute. Yeah, I can push this. Oops. Sorry for the silence, but yeah, it looks like this is taking some more time to process today. I'll quickly showcase an old existing demo report of what it generates or what it processes. Sorry, this is not the yeah. So it's called weather alert. That's the report. Or this is an old report which was generated yesterday, and yeah, so it actually processes your CSV file to generate the high risk cities, Mumbai being one, New York being the other one, Tokyo being so Mumbai and Tokyo being having a high impact, whereas New York has a medium impact, and so on and so forth. So this is what was quickly processed in the report. Yeah. So here as well, it has succeeded now. We will be able to see it. So this has triggered an email alert with the same kind of correlation analysis being generated here. Mumbai being on the high alert, Tokyo similarly on high alert, and New York being in the medium category. But one thing to notice out here is once the processing is completed, my infrastructure has stopped. I am not paying a penny more than what it required for my process to be completed, and that's very evidently available, visible in my cost explorer as well. So I have filtered all the costs based on the tags where I've named or where I've given it a project tag called zero factory zero footprint ephemeral demo, and each run for the glue job which ran for about 2 minutes, we are paying less than a cent out here. So it's about $0.02 for the complete run to have triggered. And yeah, so this is a quick demonstration of how an event driven pipeline actually kicks in. Yeah, can we go back to the slides, please?
While we come back to the slides, just a quick note to the audience, Royston, if you don't mind.
Sure. Yeah.
So, just a quick note to the audience, please, if you have any questions about the demo, about the session, anything related to our topic today, please do drop them in the comment section. We'll be having a Q&A round towards the end of the session, so we'll take them up during that time. Yeah, back to you, Royston.
Yeah, thanks, Mansa, for that. Yeah, so I know we cannot take live questions, but yeah, that's somewhere where you can push your questions, and I'll try to answer them or get back to you with the answers if the time doesn't permit today. But I just want to quickly on this slide, I just want to showcase that the cost impact. So for a traditional system which with the same infrastructure, each DPU in Glue runs with 4 core 16 gig memory, and if you have at least a minimum of 2 DPUs running anytime, if the same if we try to run in the same cloud via EC2 instances and keep them waiting for data, we are at least looking at about $1,600 per month. Traditional on-prem systems probably would charge even more because there we actually have to deal with the procurement cost of the infrastructure. But on the other hand, if you look at the Lambda cost, which is about 1/100th of a cent or 200th of a cent, and for every DPU hour, because it is running less than a couple of minutes, it's about zero point 0.1 cent. But for if you run it for a complete hour, it will charge you 0.44 cents. So yeah, that's quick about what the cost is, and let's move on to so before I I explain the slide, there might be a few senior data engineers in, or some senior people in this call who might be questioning, it's all good, when we say that we'll have to port to glue or write new lambda functions and do a bit of things there, but that's an investment that needs to be put in. How does the system fare with a lift and shift? And in most of the organization, we have Spark clusters which are on-prem, which do at least the lower bits of heavy lifting, and then our migration to the prod happens when our jobs are tested in the dev environments. So in an ephemeral environment, the same can be replicated using Elastic Kubernetes and Spark ephemeral pods using Carpenter. It's so you are easy to instances, or your on-prem machines which run your Spark nodes, they get replaced by your Carpenter pods, which simulate your Spark jobs. Your if you're using Yarn or you are using Mesos, that particular your resource manager here is actually being replaced by Keda, which is your Kubernetes event-driven auto-scaling, and your actual Spark pods, which are nothing but your executors and your driver, they get replaced by an equivalent Spark pod. So there's no change in coding required. Yes, there is a bit of investment that will still go, which is around uh, building the IAC code or infrastructure as code to define all these configurations. I'll come to a demo of that a bit later, and then it's basically lift and shift. So your core job, which does the heavy lifting of data processing, that doesn't change. The only add-on which comes in here is the infrastructure as a code width, which is necessary for all this configuration. And because we talked about infrastructure as code, that's what I have as the next slide. So we did see an ephemeral system in play, which was event driven. Whenever the data landed, it did process my data and sent out the results. But still, there is a hierarchy of clicks which I had to do to set that up. There was one missed click or one wrong step, and the entire pipeline could break. So what does IAC or infrastructure as code bring to the table? It's basically your the hierarchy of clicks is getting replaced by the code, and what that brings in is traceability. So every time any resource gets created or pulled down, you will be able to actually trace it back to the code changes that you did in your Terraform or CloudFormation or whatever that you plan to use. There will be a source of responsibility, but not at the level of the actual infrastructure. The responsibility directly comes on the code, which helps generate this infrastructure for you. And what's the beauty, or how does this change things? If you don't need something, don't just shut it down, just kill it. It's as simple as that. As I said, I'll come to the demonstration of this a bit later. But I also want to touch base on the element of cost monitoring, or how costing with DevOps, it defines the new age data platforms. So not just DevOps where your infrastructure got converted into code, but it also emphasized on one thing, is that every piece of infrastructure that you run, there is a cost associated with it. So why not track it? Why not have the right pieces of the puzzle in place, so that there is a measure of accountability in place as well for everything that you run. So that's where your cost monitoring and alerting or anomaly detection comes into play. So every resource that you create, it will have resource tags, with the right value, and we'll be able to do two things with those values. One is look at the day-to-day running cost, but with the day-to-day running cost, we'll actually be able to predict the cost for the future as well. That's what your tag-based attribution, or tag-based cost monitoring enables. And when you creating this resource via clicks in the UI, there is very easy chance that you might ignore, or you might not even see the place where these tags are enabled, but you can really enforce this when you create it using infrastructure as code. The second thing is, once we have this tag value set up, we can actually set up CloudWatch based cost anomaly detection, where in any resource, if it spikes, let's say uh, my glue job, it runs for 1 hour with 100 DPUs, and I've set an alert for that. This will automatically flag that something is wrong, because the previous runs have been lasting for about 3 minutes or 4 minutes, and all of a sudden today my job has reached the 1 hour marker, or reached the 20 minutes marker, or so on and so forth. So this is a very simple example of what anomaly detection can do for you. The third is, because this gives you power to do multiple runs with very little change, probably even trigger multiple runs overnight, you can fixate the right amount of DPU or the infrastructure that you need for your processing. Let's say you do a run with 2 DPUs, you do a run with 3, you do a run with 4, and so on and so forth, and eventually come to a conclusion that 4 DPUs, or 4 DPU is a term for glue, by the way. It can also be 4 EC2 instances which are required in my Kubernetes cluster, or something else. So I will arrive on the right size of the infrastructure by doing this performance runs. I don't need to bear the overhead of monitoring and measuring this runs, and thereby establish what's the right size for my infrastructure to run. And finally, we can do some bit of automation on our S3 tiers as well. So let's say I have been running my pipelines for a couple of years now, and some of this data is absolute, and it's no more needed. I can actually set up rules in my S3 to push this into an archive layer, or infrequent access layer, or so on and so forth. In layman terms, the hot layer, the cold layer, and probably delete it after a point in time, or just compress it in the form of a zip, so they don't need to bear the cost of a particular time. And all of these can definitely help save costs as well. So a lot spoken here. Let's look at a quick another demonstration of how the same ephemeral pipeline that we talked about, but now it comes with an element of DevOps, or DevFinOps associated with it. So what's part of this demo is, instead of this job getting created and existing in the system, we'll be creating the job on the fly. This my trigger itself will push a file, it will run the job, and I will come to know the statistics of the job. Then I will decide whether I want to keep this job, or I or I can let go of the job. So I'll once again go to a screen share.
Can we have the screen?
Yeah, it's here.
No, 1 second. There you go.
Yeah, perfect. So a quick thing here is, uh, this particular job is created via Terraform. So all my configuration which is needed, which version of Glue I'm going to run, how many worker nodes I'm going to look at, what type of worker node or worker type I'm looking at is G1X. I can actually let me quickly do a change so that it looks real time. I will change the workers to 3. I'll just commit this change saying I'll say worker no change. I commit my changes, and I'll quickly run a job, which is a code build job. Uh, it takes a few seconds, but we'll be able to quickly see a new job in my glue area. So currently there is only one job which is present here. And once the code build has completed the execution, we'll see that a new job with 3 DPUs is actually kicked in. Give it a few seconds. Yeah. So in again, I'll come back to the same code. So every configuration, even including uploading the script files or uploading the S3 buckets, the files to the S3 bucket, or the trigger for my job, which once created should be automatically running with 3 DPUs assigned to it. All of that here is provisioned as infrastructure as code. So this is what and whatever tags that we pushed, or whatever tags we said that we will attach to the job, so that we are able to monitor the cost. Those tags or those values are placed in my infrastructure as code, or my Terraform code itself. Let's go here quickly. So this has completed, and we'll refresh the jobs. Let it go. Yeah, we'll refresh the jobs here. Yeah, so now we see that there is a second job called demo2 for correlation. We'll go to the job details here quickly and see that this is working or requesting 3 worker nodes. And the run for the job has also begun. It's fairly the same job. It's in progress working with 3 DPUs. So this is what the job it gets created, and it's running in the background. This is also a very similar job, but the file is being placed in an automated fashion. So you don't really need to worry about. So we are simulating a trigger using Terraform itself. When this completes as well, we'll see that this also generates a notification. Let's wait for it for a couple of seconds. Yeah, so this has succeeded. I'll go back to my mail, and I can quickly check here. It's called demo2 successful, the same file, which was published, or which was uh, yeah. So this also generates a very simple result and notification. And once the job is completed, or once the job has finished running, if we are happy with the statistics or the performance of this job, we are good. Or we can keep the statistics to showcase to our managers, or say that, okay, we have got X amount of performance thing, or my event driven analysis is completed, or the job which I was supposed to run, that's completed. We just go and call a destroy on this job. So let's say I don't need this job anymore. I just whatever statistics that I wanted, that data is stored. I have already got the notifications which I was needed, and then because again it goes with us our call for today, zero footprint. We don't need the actual footprint of the processes which have triggered, and for this one we don't even need the logs or the actual run significance out there. So we just call it that this is done, close, and once the job completes, we are we'll see that the job itself is deleted with all background vanished. Let's give it a few more seconds. Any moment now. Yeah, so this is what it will delete. Yeah, and it's finally deleting the job. So yeah, this marks that the process is completed. Now we are good to refresh our page. And with this, the job which we ran as a trigger or as a test with three DPUs, after generating the result and lasting for 1 minute, not just the job was deleted, or sorry, the job was successful and completed. We have taken the data and after that completely killed the existence of that job altogether. So yeah, this is what sort of a game-changing experience or impact that CI/CD or DevOps brings to your data platforms. Yeah. Now we can can we share back the presentation? Yeah, quickly, it's already there. So what are the advantages of a zero footprint ecosystem? Definitely, there's enough of cost saving, and we have seen that a process which would have meant that for a file to arrive, it would have been pinging my S3 bucket that did a new file come in or did a new event occur, and for that my infrastructure would be running 24/7 because files can be generated at any time. We are reducing that amount to probably a few cents out there. This also gives us the elasticity. So we changed from two DPUs to three DPUs, and all the three DPUs were provisioned in that moment for that job to run. I have absolute zero overhead. I don't really need to manage what patches to apply, what security changes were recommended by the global forums. Nothing of that sort. It's all taken off by the teams or the people sitting in the background. There is reproducibility or traceability introduced with the advent of infrastructure as code, where I can go back, I can actually create a parallel platform in itself to simulate a situation or create a run and then get rid of that entire platform without leaving any trace. It just completely vanishes. So that makes our life much more easier, gives us the power of uh, like you know standing tall and not being worried in case of in any disaster or anything of that sort. And finally, because all of these comes baked in with cost or cost governance, every move that we do, every thing that we trigger, we can actually either charge back to our customers or very well still be in the place saying the old infrastructure costed X. I am probably at 1/20th, sorry, 1/5 of that X value, and running the same infrastructure, running the same amount of data processing, because all of these is really traceable via my cost explorer platform. And I will also be able to create budgets for the next cycles with a hint of predictability that if today's run or this month's run costed me X, if my data increases to 2X or my infrastructure increases by 4X, my cost will be 4X or so on and so forth. So that's what are the advantages of what a zero footprint ecosystem brings in. Yeah, and I'll take a quick pause here and then jump to, so what are the key takeaways from our today's learning? So we did see that zero footprint eliminates the idle resource cost, which is probably the highest amount of cost on any traditional data ecosystem which is running. Infrastructure as code, for our case Terraform, when it paired with serverless, it's a game changing experience because we get a complete amount of reproducibility and traceability, and still live with a zero ops platform where we don't really need somebody continuously monitoring or looking at the platform. Event-driven ETL, which is the first demonstration that we saw, it it can definitely scale. It can the file today is 1 megabyte. If it increases to a few hundred megabytes or 1 gigabyte, it has the power to scale for the kind of data that you have pushed in and yet deliver the results. And eventually, because all of these is tied together using cost tags or resource tags, we are able to track the cost of each execution or each resource being utilized with the right with the right value, and thereby either do a chargeback or bring in an element of governance where we don't spend more, especially when the impact of that particular transformation or that particular ETL is much lower. So these were the key takeaways, and I think so. The next move for all of you guys would be take any low risk or take something which is out there in your ecosystem. Just try your hands at to convert it into an ephemeral mode, or I'll be sharing this particular code in my private repository. In my public repository, you can actually take that and try your hands with the same. Thank you.
Thank you so much, Royston. Thank you for the insightful session and for walking us through how zero footprint and ephemeral data platforms are today reshaping the modern way of modern data and AI systems are built on AWS. Now we'll open the floor to some questions. Again, a quick note to the audience: please drop your questions in the comment section. We'll take them one by one. So we have the first question on the screen. This is from Kajal. The question is, the weather CSV demo works perfectly, but how do you validate data quality in production? What if rainfall _mm contains negative values or city names are malformed?
Yeah, so let me answer that. Again, there are options which are inbuilt, or we can look for open source options as well. Both well rooted with the demonstration that we build using Glue, because Glue has options for Python, it has options for Java, it has options for JavaScript and so on and so forth. But even if you focus on Python, there is a Glue data quality or Glue DQ which is available, or you can pair with any open source library like Great Expectations, say for example, where we can apply validation saying rainfall greater than 0, or the city names which are standardized in nature. We can just have a separate piece in the pipeline saying we can either filter out all the invalid rows and only go ahead with the processing if my data count or the row count is probably at the 95% or 98% mark, or the entire file we can actually place in a quarantine bucket where somebody, or we go back to the provider team saying this data has some inconsistency in it and we need to really validate it. But it's coming back, it's very simple. Use it. You can use either Glue data quality, which is again inbuilt, or can look at any open source library like Great Expectations.
Okay. Thank you so much for answering that, Royston. We have our next question from Zahir. What if the Lambda Glue handoff fails mid-file? How do you guarantee exactly once processing and avoid duplicate process CSV files?
Good. So this is a very very valid question, because there can be any kind of issue. There can be either because you have attached a security group or a VPC, and that's the reason the Lambda is not able to call your Glue job. Or second thing is the service account role which is associated with your Lambda, that is not able to trigger the Glue job because it doesn't have the permission. So that can there can be multiple reasons for this handoff to fail, in mid of the process. But there are multiple ways to ensure that this particular process is end to end completed, and it happens only once. We can bring in a FIFO queue between Lambda and Glue. So my file name or my file path can be pushed as part of the FIFO queue, first in, first out. Whenever the message from that queue is processed, we can ensure that it doesn't reprocess the file again. That is one way. The second, we can do is that there's an option to do glue job benchmarking, where we can insert some sort of a benchmark in your job. So not benchmarks, it's called bookmarks. So it's you have read a book, you have reached a bookmark in your glue, in your book. So that's the bookmark which you introduced for reading it next time. So it's exactly works on the same phenomena where you reach a particular point in glue which failed, and then next time when the job triggers, it just does the processing from the bookmark which you had introduced. So there are multiple ways, but these are the two very simple, easy ways. And last but not the least, if at all nothing works, there is a glue dead letter queue or a DLQ, which is an option which becomes available. So any failure can be tracked as part of your DLQ, and your job, when it triggers again, it can read from the DLQ and reprocess the data. This will ensure that the same file is read only once and not having multiple runs on the same file.
Thank you so much again, Royston, for that really informative answer. I hope that answers your question, Zahir. We have the next question up on the screen from Kinjal. Hi, Royston. In your demo, Lambda triggers glue instantly. But what happens during cold starts? How do you generate sub-second pipeline startups for production SLA?
Excellent question again. So anything which sleeps or which is serverless will have a cold start. That is for sure. But so this is same behavior that we can have across cloud environments. AWS gives us a provisioned concurrency, or especially if you're talking about Lambda. So we can set provision concurrency for up to 10 Lambda functions, where you are there will be a Lambda function which is warming up, and for an event to occur, for a process, or for a trigger to be executed. So there's always something which is in a provision capacity which is running. So whenever such thing is actually triggered or event occurs, it will immediately kick off. With that, you still don't pay the entire cost which is applicable for your Lambda function to be running 24/7. You still pay about 10 to 20% of the cost, but you are actually saving about 90% of the time which goes in your cold start. So that's one way where using your provision capacity up to 10 Lambda instances is what you can have in in a almost running kind of capacity. Yeah.
Thank you, Royston. We have one last question. I hope it's all right. We can take it.
Sure, yeah.
So we have a question from Achal. Hi, Royston. Your demo processed 100 cities in seconds. How does this scale to 1 million cities daily? Do you switch to EKS, Ephemeral, Spark pods at that volume? Over to you.
Yeah. So, again, your data load is not the only pointer for which you change your infrastructure. It is definitely one in terms of how much data you are planning to process, but only data doesn't define whether you should change from glue to EKS, ephemeral Spark pods or something else, or have a 24/7 running EMR, which is Elastic Map Reduce, or HD Insights running for you. Glue can easily scale up to 100 plus nodes in the same amount of cold start timing, which is a few milliseconds out there. So 100 cities to 1 million cities, fairly easy to be done using glue. On the other hand, this EKS ephemeral Spark pods, they have a purpose, or they have one is any ML driven or ML pipeline which you're looking at, especially when you're scanning through large amounts of data. And when I say scanning, it's a select star kind of query. That's where you look at and EKS. So EKS is more or less like a fallback option for ML machine learning kind of requirements and so on and so forth. Because there's a cost factor which also comes in between EKS versus your glue. But anything up to like a few million, let's say 10 to 20 million rows, it's very easy to be processed using your glue job. You don't really need to like change the underlying infrastructure or technology in itself.
Great. That's the end of our questions today. Thank you so much, Royston. Once again, thank you for taking us through the topic and the demos that you presented. I'm sure we have all learned something really insightful today. Um, Thank you to the audience. Thank you, everyone who joined us and stayed engaged throughout the session. We hope today's discussion gave you a new perspective on building more agile, cost effective, efficient, and scalable data platforms. So, we will be sharing the recordings and the key takeaways shortly. So, please stay posted or stay vigilant on our page. If you have any follow up questions or would you like to continue the conversation, please feel free to reach us out. The details will be presented on the screen. There you go. Thank you so much again. Thanks, Royston. Have a good day ahead.
Thank you.